Hi everyone, welcome to the low temperature thermochronology course. Today we are going to share an application case, Paleotemperature and Maturity Evolutionary History of Salt Rocks in the Ordos Basin. In this section, 6 topics will be discussed, including the introduction of this work, thickness and maturity of salt rocks, present-day geothermal field, maximum gradient and thermal anomaly, denudation and 3D modeling, tectonothermal history of a cross-section. The Ordos Basin is located to the north of the Qinling origin in East Asia and enriches Mesozoic and Paleozoic conventional and unconventional oil and gas resources, such as shale gas and tight oil. Salt rocks are material basis for hydrocarbon generation and accumulation. Paleotemperature and maturity evolution of the salt rocks play an important role in hydrocarbon accumulation and petroleum exploration. 3 sets of salt rocks shown in the red figure are the Yanchuan Formation of Upper Triassic, the Shanxi Taiyuan Formations of Lower Permian, the Majiagou Formation of Lower Ordos Basin. Research of paleotemperature and maturity evolution history of these salt rocks is not well understood, which restricts petroleum geologists to deeply understand the hydrocarbon accumulation and exploration of the Ordos Basin. Based on thickness of mudstone and coal seam of the Shanxi Taiyuan formations from 312 drilling wells, thickness map of the upper Paleozoic salt rocks was made, based on salt rock data of the Yanchuan Formation collected from 290 wells. Thickness of the Yanchuan salt rock was calculated using the well logging method. The relationship of present-day temperature and depth was made based on steady-state temperature data from some drilling wells. Data from many wells, but only some are listed here. It can be seen that the present-day temperature of the basin increases linearly with depth, with the temperature gradient of 2.9 centigrade every 100 meters. According to the present-day temperature data and thermal conductivity of 354 rock samples, the heat flow was calculated and shown as the red figure. What we showed above is the present-day features of the Ordos Basin. Next 3 topics will focus on the recovery of the paleotemperature and cooling history. The relationship of RO and depth reflects the thermal effect of the late Mesozoic geothermal field of the Ordos Basin. The maximum paleotemperature corresponding to each RO data were calculated based on the relationship between the maximum temperature as Tmax and the average Visionat reflectance. Mudstone Visionat reflectance of 4 formations shows that RO value increased from basin margin to the abnormal area. The high values of different formations are roughly distributed at the same area, which is the Wuqi, Qingyang, Fuxian area in southern of the Ordos Basin. The total erosional thickness of the Ordos Basin since late of early Cretaceous was calculated using the virtual net reflectance method, the acoustic logging method, and the stratigraphic correlation method. The software of Petromod was used to establish a 3D geological model as the red figure, and the uplift denudation rate and amount were constrained by a series published data of habitat fishing track as the middle figure. Habitat Zircon helium, virtual net reflectance, and combined with denudation thickness and present-day buried depths. Tectonothermal history of an east-west cross-section in southern part of the Ordos Basin, which causes several tectonic units and drilling wells, was recovered. The simulation processes are restrained by the results from data of low-temperature thermochronology, especially fishing track data, with tectonic movements and sedimentations from Proterozoic to early Carboniferous. Deposition occurred again at late Carboniferous, and considerable organic-rich core measures were developed in the Permian strata. Paleotemperature of both the Upper Triassic series and the Permian system, which are considered as the primary source rocks, began to increase since Triassic, followed by gradually decrease since late of early Cretaceous. Paleotemperature of the Qingyang Fuxian area were higher than other places of this basin, indicating a significant thermal abnormal event occurred from late Jurassic to early Cretaceous, and the most potential place for oil and gas exploration. From this lesson, we can see that thermochronology is an important technique for paleotemperature recovery of source rocks and would be very useful for further petroleum exploration. That's all for this lesson. Next time, we will talk about the Mesoceanozoic cooling history of the Weibe Uplift Ordos Basin. See you then!